Greetings, fellow Homo sapiens, and welcome to the Symbiotic podcast. Today, I'm very excited to have three guests from Penn State with me. I've got Moriah Szpara, who is Associate Professor of Biology, Biochemistry, and Molecular Biology at Penn State, Tim Simpson, Professor of Mechanical and Industrial Engineering, and Melissa James, Facilities Coordinator at the Eva J. Pell Lab, Penn State's Animal Biosecurity Level 3 facility. Welcome to the podcast, everybody. Today, we're going to be talking about a really exciting project at Penn State called the MASC project. That's MASC. It stands for Manufacturing and Sterilization for COVID-19. And I'm going to start off by asking Tim Simpson, who's sort of been heading this up, to give us a little overview of what the MASC project is all about. Tim?
So MASC is really an interdisciplinary group of faculty, students, alumni, doctors, clinicians, sort of you name it, that have all sort of come together to help address sort of the needs from supply chain shortages and not enough PPE to better sterilization protocols to help improve the utilization of personal protective equipment and devices that are in short supply or high demand at the moment. Like a lot of these opportunities, it actually started with sort of an open source design that was shared widely around the world. Actually, a group in Czechoslovakia had posted with this company Prusa, had posted a design, face shield that they had developed in 3 or 4 days, made it available online. Everybody started sharing it, tweaking it, improving it. We made our own modifications, Applied Research Lab, working with them closely to 3D print it, get the right plastic in, lasers cut it, get this up and running. You know, we do a lot of work on 3D printing and the ability to very quickly iterate on designs and ideas, try them out and evaluate them as you're trying to address either, short-term needs or a stopgap while other solutions come online. End of the day, though, Penn State is not a manufacturer, right, other than ice cream. And we don't have product liability insurance except for ice cream. So we got to find company partners to work with. And so here's an example early on with Hershey. The president of the medical center was trying out some of the masks with a local company, UPPI, that's right in the neighborhood, that's now making thousands of masks a day, and it has basically met their need. Here in State College, we've been working with medical companies as well, like Actuated Medical, that are GMP compliant. You still need, the FDA is still regulating devices and these sorts of things, so you still have to make sure you meet all the standards and whatnot. So working with companies to do that. And really, collaboration has been critical to our success, both in the manufacturing space and the sterilization space, in particular, what Melissa and Moriah and their team have been doing in that regard. A couple of pictures here of sort of like all the different mask designs we've been 3D printing and testing, working with the doctors at Hershey, Dr. Clark there with one of the masks early on, architecture students and engineers that came together to create an isolation booth that somebody would sit in. If you didn't have a mask, 3D printed test swabs that are in short supply. I mean, you can sort of see from the diagram, it's engineering, it's medicine, it's the community, it's Commonwealth campuses. We actually have faculty and students at over a half a dozen of our campuses that are helping to make face shields and other PPE and related things for their local community and hospitals. So collaboration is key, and really the way we sort of keep this on tune and on focus. We have a call every day at Hershey, and I'm not going through all the details here, but just to show you, this was our very first spreadsheet. There was maybe 8, 9, 10 of us on the call, was sort of, hey, we need this, we're short on this, we're that, to by the end of the week, it was color code. It was red is, oh, this is bad. Yellows, maybe green is, okay, we're kind of good. We've got charts and layout. This morning we've got on our call, we had over 43 active projects. You can see sort of the range of things that have gone from yellow to green to red. Unfortunately, last week, as FDA pulled approvals on about 80% of the mask suppliers in China, all of a sudden, everything that was sort of going okay is now up in the air again. Hershey was expecting many of those masks to come by. So, what are the supply chain needs? We've got the VP of sourcing that's on there along with doctors and everything. We have leads at each area, both with at Hershey and the Health Center, University Park, the Center for Medical Innovation there. And we've actually, again, to address the regulatory issues, end of the day, are these devices and things safe? Do they meet the standards that are out there? And so we actually have a Penn State Health Emergency Response Team, or PCERT, so that set up a quality system So we go from the start, hey, here's the need, here's the requirements, here's where it's short, this sort of stuff, and be that a new device or a solution or a new mask or a new sterilization protocol. We actually have a process now to go through this, vet it with the right people, make sure that everything is on target. When it's all said and done, we've actually got on our website, mass.psu.edu. We're posting everything there that now anybody can use this as a resource. So from, what's the need, to IP concerns, to sterilization protocols, to supply chain. We've got a whole sourcing group that's identifying potential suppliers. And I think it just really goes to show, again, within 6 or 7 weeks, we're over 350 people that are on our listserv now, getting updates. We've got 24 units. You can see some of those from College of Engineering, the Pell Lab, Penn State Health, and Hershey, of course, all the many of the institutes and whatnot. It's really been a great effort and a great team doing some phenomenal work. So thank you.
Yeah, thanks, Tim. That is so fantastic. As I was just saying, with this podcast, we're talking about things that we can only do through collaboration, and this is such a fantastic example of that. So congratulations for getting this off the ground, and I love the fact that something came from Czechoslovakia that was adopted here and jumped on, and that it spread so quickly and everybody rallying behind that. That's the big story right now, is scientists all over the world coming together to deal with this common threat that we all have to address as one global community. And this is a fantastic representation of that. Real quickly, you showed some measurable outcomes in terms of, you put this out with that sort of open source science. Anybody can go there and access these resources, correct? And kind of, yes, as a model to take on a similar thing wherever they're located in the world. Is that the idea there?
Correct. Yeah. So we've sort of, and obviously there are some tricky, what you could do in Czechoslovakia or Italy as well. There was a big thing on 3D printing replacement parts for ventilators that then now the company was threatening to sue them and this and that, and sort of all the, the regulatory pathways and legal, et cetera, we have to deal with in the US are a bit different. But we've actually connected very early on. Michael Brignotti here in the Office of General Counsel is sort of right with the team to help us advise on sort of what we can and can't say or post and share. We sort of have an internal Microsoft Teams that we're using for sort of batting ideas around and prototyping. And then once something sort of, gets post approvals and or, we've got data to share, that gets reviewed and posted on the website for then anybody to take a look at. And for companies that we're working with, we've got non-exclusive royalty-free licenses to basically, the goal is to hand off and get it as quickly as possible to a mass-produced solution. So it's amazing what we've been able to do in such a quick turnaround time, given the urgency and demands that we're seeing.
Cool. Just one more follow-up before I kind of switch over to our other guests and start to bring them into the conversation. And that is about numbers. Are you tracking numbers of, how many printed pieces have been created and so forth? Is that something you're able to even, track as this open source world of, you don't know what people are doing with it? Are you aware?
No, it's tough to do. So I know I have, 153 printers sort of on hand and ready and willing. We can sort of pull people and get sort of rough numbers. I know companies are in, we're at, thousands per day in some cases. I know, Actuated Medical's they're up to about 20,000 face shields now that they've been producing. So it's tough to track everything. But it is, there's certainly high demand. And I think even though the 3D printing is great, you're sort of seeing in the maker community, the sharing and exchange of ideas, very similar to what's going on in sort of the scientific community. And you are seeing, hundreds to thousands to tens of thousands. The trick though with 3D printing, given the time it takes to print something, I sort of joke we would need to fill Beaver Stadium with 3D printers to sort of meet the needs at Hershey alone, right? So, wow. And we're in a pretty good situation. Imagine Philly or New York City or San Francisco. You got to be able to sort of use this to get to sort of mass production much more quickly and find, the partners to scale up and sort of transform their production to really pivot and transform their production to really address this huge need that there are not enough 3D printers in the world to satisfy right now.
Yeah, a lot of pivoting and a lot of transformation happening, from GM
Absolutely.
to you name it, all over the place.
Well,
Well,
and
Mariah,
the other,
oh,
just real
pardon me.
quick, the other piece there is that even though everything's sort of being shared globally, it ends up really critical. Can you put together like a local supply chain to actually deliver final solutions to, a hospital? So even though we could 3D print as many masks as we wanted to, if you can't find the plastic shield or if you can't find the filtration material right locally, it's going to take, for a while, the factories in China were shut down, but let alone even now it's months delay. So now you have to turn around and locally source everything. So the push for global collaboration and domestic manufacturing to address these needs, it's a very interesting and unusual dynamic that I don't think we've seen before.
So this is revealing so many things. What's going on under the
Yeah,
surface? So many levels. This
yeah.
pandemic, where social things and manufacturing and systems. It's all in our face now. A lot of things we have to rework and look at it with fresh eyes and find some new solutions.
Yep. Thank
So
you.
I'm gonna switch to Moriah. Moriah, how did you get involved in this mask project? Could you tell us that story?
Sure, I can tell you that story. So I am contributing to a piece of the mask project that isn't so much about printing and creating new objects, but instead being able to safely reuse the very precious personal protective equipment that's called an N95 respirator, or in common parlance, just a mask. And those particular masks are worn by healthcare providers because healthcare providers tend to be in a situation where they could be exposed to a high dose of pathogen, for instance, from a coughing patient or someone being intubated. And with the supply chains disrupted, one of the most important factors is to be able to either conserve and limit the use of N95s that you have, or more importantly, to be able to take them and in some way sterilize or decontaminate them and reuse them. So back maybe a month ago, about end of March, I was asked to sit in on a meeting with some other members of the mask initiative from Environmental Health and Safety Office, Melissa James on behalf of the BSL-3, and a number of other clinicians and scientists to ask this question of whether or not it would be safe to decontaminate and reuse these N95 masks. And in particular, because the pandemic that we're dealing with is spread by people coughing and sneezing or exhaling simply, if they were an asymptomatically infected person, it's really important that you sterilize not only the outside of this piece of personal protective equipment, which sits on a person's face, but also the inside, so that a wearer who did not realize that they were ill could have their mask be decontaminated and safely put it back on again without contaminating them. And so that was really important to be able to show that you could fully inactivate things on this kind of equipment.
You said it was just a month ago. I know you sent a quote about the speed of this thing within 3 weeks. I mean, you just kind of dumped in, and then within weeks, I think you had published some research, a preprint on the server Med Archive, with like 3 weeks into the project, you had run some tests and were publishing something. Is that correct?
Yeah, it's a really important piece of the story to say that I got asked to come in and consult to the group because they had read someone else's preprint, where a group at Yale had done a similar study to what we then conducted, and using the particular equipment and facilities available at Yale showed that they could decontaminate something. And so I was brought in to say, could we do this? Could we do it exactly that way? Or if we couldn't do it their way, could we do it our own way that would prove the same goal? And I don't think myself or any of the other scientists who contributed to this effort, whether that was permissions or sourcing of reagents or the physical work, we've never worked so hard and fast in our lives. I think all of our families wondered, where are they and why are they not home on this special day or weekend or evening? And why are they doing this again? But we really needed to have it done and ready as fast as people would be landing in an ER in a hospital room, needing to have their physicians and clinicians in PPE. So we did work hard and fast, and we wanted to really return the favor to the people whose preprints we built our work on. And so it was really important to not just do it and share the results within Penn State, which we did, but to be able to put this preprint out there in a way that anyone could pick it up, see what we did, and reproduce it at their place. And so it's a full paper with all of the methods and data analysis intact, but later we will submit it for peer review at a journal where it will be evaluated by peers and probably undergo further improvements before it becomes a fully published piece of material. But during this pandemic, as I'm sure you'll want to talk about later, many things are being shared on preprint servers to be able to allow people to get fast access.
Yeah, I'm really fascinated by that. because it's faster. It comes with its own challenges, right? Because the group, almost like a Wikipedia situation, there's not a peer review, but yet all these peers are going to the preprints. Was this your first time publishing to a preprint server like that?
No, we have used them before. We've used them sometimes to be able to share work when we want to be able to give a talk at a conference. That's actually where my experience started, was because I wanted to share the data behind something where I had a 12-minute talk at a conference. And in order to share the rest of the data with the world, I said, here is my talk, and then come and see the rest of the data at this preprint server. And since then, we've sometimes used it as a way to just share data more quickly, or to be able to share it during the process of peer review, because peer review is really important for improving the quality of scientific work, but it can take up to a year sometimes for the process of peer review. And then even when something is reviewed, it can sit on the servers of the publication before actually appearing in a print issue or an online issue, when it's already fully vetted, but still not available to the world. And we often have shared our work at that stage, because it's really important to share things early.
Right. I mean, we've run into that with our podcast. We've had guests on that said, well, I really want to share this latest, coolest thing I've done. And I think by the time your podcast is out, we'll be able to share it. And then we had to cut out a whole, like, the coolest part of the talk, because like, oh, no, it's too early. Right. So, but this pandemic has kind of blown the doors off of that whole approach and said, no, we need to get it out. So, I mean, do you find that you and your colleagues are going to those preprint servers more than ever before and scouring those? I mean, I know people are trying to use AI to get in there and find terms and make more of a dashboard for everybody. Can you speak to that a little bit?
So I think that the value of bioRxiv and medRxiv is enormous, but I have to say that I think that the pandemic has not only revealed the power and the awesomeness of these resources, but also the potential detriment. There are people who put out unduly provocative work that has an unfair or unjustified title, or makes claims that aren't substantiated. And it can be really difficult for people who are non-experts to sort out which pieces of work are quite provocative, unduly so, and which ones may be provocative but are fully justified. And this is a really exciting place to share that data. And as a scientist, I find that it's very important for me to see the responses of other scientists, whether that's comments right at the peer review archive, or sometimes on scientific Twitter or other blog and opinion pieces in science news journals can be a more rapid way, for instance, to put out a short letter or an opinion piece that comments on someone else's work. But that is part of the process that I think the pandemic is changing for the better. More people are aware that these servers exist, but it also leads to a little bit of cracking open the door to some misuse of that ability to rapidly share. And science is good at self-correcting over time, so bad actors will be weeded out. But that's harder to address in the public eye, and you don't want to have people who are non-scientists distrusting all of science because of our freedom of information and allowing sharing from anyone who wishes to deposit something.
Right. And that's already such a struggle for people who don't want to believe science. That's a whole other podcast. We touch on that sometimes as well. The belief systems that the public brings, or different people in the public and in different groups. Wow, thanks for that. I do want to include Melissa in here and ask her a question too. Melissa, you work in the EVA Pell lab, and that's a biosecurity level 3 lab. I've heard that you have to, get fingerprinted by the FBI just to even walk into that lab. Is that correct?
Yes, so everyone who works in the laboratory, they undergo a security risk assessment, and that includes fingerprints and a background check by the FBI. That's correct.
Melissa, can you talk to us about how you ended up working in the mask project?
Yeah, so similar to Moriah, I was approached by our environmental health and safety group. And so they asked what types of decontamination units did we already employ at University Park. And so the Pell lab, being a biosafety level 3, we routinely do decontaminations of spaces and equipment with hydrogen peroxide. And we have 2 different types of units, one that's very similar to the ones used at Yale, Duke, and Pell early on in the N95 decontamination process. And they use about 30 to 35% of very concentrated liquid hydrogen peroxide, and they put it into a vapor form. And so we have that capability and the equipment to do that, but we're also using a newer technology that uses aerosolized hydrogen peroxide at 7%, so much lower concentration of the liquid hydrogen peroxide and much less toxic to the people who are using it and the process of it. And so we wanted to prove that, okay, we know we know that the 30 and 35% vaporized hydrogen peroxide will work, but could we bring something a little bit different, a little bit faster, more non-toxic, using the aerosolized hydrogen peroxide technology? And that's what we've shown with the virology and the spore tests that we've done. Filtration testing is undergoing, and then also the mask fit tests. And so it's important that once you treat the PPE, the masks that you're treating, with the hydrogen peroxide or whatever decontamination process you're using, it's important that they work afterwards. And so it's important that we get the right fit to make sure that the seal that's around the user's face is still adequate, and that you're getting the protection that you think you do from a brand new mask.
So essentially, Yale had this sort of proof of concept, threw it out there, and then here at Penn State, we took that and refined it and made it a little less toxic and spent a little more time talking about, does it fit? And I remember reading the release about it, said that you found that up to 10 times you could basically get 10 times as much use out of an N95 mask as you would otherwise. Is that correct?
Oh, definitely. Yeah. And with this lower percentage hydrogen peroxide, I think you could get much more rounds without affecting the filter material. But practically, hospitals are stopping at about 5 or 6 rounds, basically because of the way that the mask is used. It can be contaminated with other things like blood that makes it non-usable anymore. And then there's other limitations, the material, the strap material, just flexing it so many times, putting it on over your head, that's going to be a limitation in the material, not necessarily due to the processes that it's been through.
Thank you. Thanks very much. And one question before we take a little break, and we'll come back with part 2, but I throw this out to the group. With this latest preprint that went out about decontaminating the N95s, have you as a group received much feedback from others? Are others now taking it to another level, or do you get feedback from others, or you kind of put it out there and you don't always know who's going to take it or what they're going to do with it? How much do you know about others jumping in on this as well?
Yeah, so I can talk with that a little bit. There's a group, consortium, the N95decon.org. Is their website, the N95 Decon Consortium, where they gather material like this and see what people around the world have been doing, and compile the data and compare everything. And so they're looking at things from a scientific view to make sure that, okay, it's not somebody who's just doing this in their backyard. They really have some validity behind what they're doing, and that it can be used for others. So that's one of the groups that's compiling this information to be used for other people.
Very cool. I love it. Like all these different sites cropping up for these little niche groups that all are playing a part in this bigger story. Very cool. Well, I'm Cole Hans. This is the Symbiotic Podcast. We're going to take a quick break and we'll be right back to speak to our guests about what they see for the future of science post-pandemic. Thanks a lot. Stick around. The Huck Institutes of the Life Sciences at Penn State offers 6 inter-college graduate degree programs in bioinformatics and genomics, ecology, integrative and biomedical physiology, molecular, cellular, and integrative biosciences, neuroscience, and plant biology. We also offer an accelerated professional science master's program in biotechnology. At the Huck, we immerse students in a groundbreaking environment built on interdisciplinary collaboration among some of the world's most innovative research scientists, and our students receive unparalleled access to bleeding-edge technology in world-class core facilities. If you're looking for a deeper, more holistic grad school experience, you owe it to yourself to look at the Huck. Visit us online today at huck.psu.edu. Welcome back, everybody. I'm Cole Hans. This is the Symbiotic Podcast, and this is part 2 of our conversation with 3 of my colleagues from Penn State who have been working on just a fantastic project that we call the MASK Initiative. Before we start talking about the future of science, I just want to ask the group again, what are some of the unique things that Penn State brought to this basic research that came from Yale, put on a preprint? We kind of picked it up and ran with it. So could the group kind of break out a little bit more for me of what did we do with that?
Yeah, sure. I can start just to say that when I was brought in to consult and offer an opinion about what was going on, I also not just offered my opinion, but listened to the other folks who were on the line. And in particular, the medical consultants who were brought in from Hershey, that's their version of environmental health and safety, as well as MDs, thought it was pretty important that we not only test the ability to decontaminate bacteriophage, which is what had been used in the Yale study, but also address the ability of whatever methods we would pick to inactivate human infecting viruses, and in particular, to include human respiratory viruses and even the SARS coronavirus 2 itself in that study. And so we have been able to incorporate each of those pieces into the puzzle. And I think that's been an important additional contribution to what was done before.
Thank you. Others?
Sure, I'll add to that. I mean, I think the other unique aspect there is because of the diversity of the team. We had EHS, Environmental Health and Safety, was part of the initial discussions. Melissa James was on there, Jim Crandall, which is the director here at University of Park, and then Hans Durr stepped up and helped with that. You know, these are staff folks that are not usually doing research and certainly not co-authoring papers that are now listed on this as well. So that was just phenomenal to see, to advance that. And then I think as I read the paper, was surprised that nobody had done the actual fit testing and or the actual virologic studies that we had been doing. So it was like, duh, you'd think you would have studied that, but they didn't. And then in terms of where it's going next, we've actually been handing that work and the other sort of background research that everybody's gathered to a group of architects, facilities engineering experts, and others to actually look at how do we now fit out rooms to actually do and conduct this work at a hospital. And so the big challenge now is, hey, it's great, I have this system, but how do I dedicate a room to it? And or what's that going to cost? And what's the right type of room? So now you need architectural engineering, you need architects. We've got a business analyst on the team to help look at sort of what the costs are going to be. We've even got a special effects company. I love this one. A friend that had
wow.
They make sets for MacGyver of all shows right now. So they're
That's
ready.
an engineer's dream.
It is. It's awesome. So they're ready to start cutting up a shipping container and put whatever we need in it and drop it in here. I mean, so it's in some of these it's just fun to be able to pull a group like that together and sort of try and solve a problem. So I mean, it's MacGyver-esque in and of itself, let alone. So it's just, the folks that we have here and the expertise to attack these problems has been great.
Yeah.
Fantastic.
And one of the things we didn't talk about was the space that you decontaminated in. And so there's a lot of places like hospitals and laboratories that have smooth, easy to clean, sanitizable surfaces, but they don't all have the ability to shut down the airflow or completely seal a room to make it gas tight. And so one of the things that you need to be able to hold this fumigant inside the space that you're decontaminating is that gas tight seal. And so that's something that's a little bit difficult to engineer in if you don't have it already. So biosafety level 3 laboratories usually have it already because it's part of our procedures to decontaminate the spaces. But to do that or retrofit it into a place that doesn't have it can be a little bit more challenging.
So obviously, we are very actively participating here at Penn State with this global community. We're talking about Czechoslovakia, we're talking about Yale, we're talking about a global place for N95 best practices, right? How much do you folks see this sort of disruptive transformational moment in science, changing the future of science, say like post-pandemic? I mean, I think we're going to be in this pandemic for how long do we know? A year, 2 years? I mean, this whole world of, social distancing and going out and coming back and working on vaccines. And it was like 200 vaccine projects going on with people sharing that data with one another. But, it strikes me that this is such a disruptive moment that science maybe won't be the same after. Can any of you give me sort of your visions or your take on that as scientists living through the middle of it now?
I mean, I'm happy to at least comment about following up on your query earlier about scientific publishing, that I think in addition to scientists jumping in and contributing their expertise, a number of publishers and providers, for instance, of textbooks for those of us who are teaching during this pandemic, other content providers have stepped up and made all things related to COVID-19 and actually meant much of their other content available online free. And it may be that journals step up the release of publications that are sitting already approved in the queue, and other steps like that to be able to make things accessible faster to the general public. And so I think that would be great. And I hope that that's a lasting outcome of this. On the other hand, we're generating a tremendous backlog in science right now. The number of peer reviewers to review COVID-19 related research or any other virology right now is extremely limited. And I say this as a virologist because I'm working on this support project. I can't review as many papers, and many of my peers are doing the same thing. So there's a backlog of unrelated to COVID-19 research that's piling up that I hope will get cleared when we all start to get back to work, but it's an unseen consequence of what's happening, that other research is being held up while this is racing forward. So there's both good things and then tricky things that we have to figure out how to counterbalance. And I think that push and pull in science, that's felt by people who want to be safe, but also want to return to work. And so it's not unique to science. It's just a part of it that may be less in the public eye.
Thank you for sharing that. Yeah, that is the inside scoop of what's going on. Tim, Melissa, do you have any thoughts about how this disruptive moment might change things moving forward?
I agree. I mean, I think this has really put a fine focus, if you will, on sort of a lot of the shortcomings certainly in the supply chain and engineering side and the regulatory. I think even in the way that we're sharing and exchanging data and information. We've seen this in my own world within 3D printing, for instance, just the amount of sort of discoveries and things that are needed relative to the advancement of the technology. There's sort of, to write a proposal, to do a study, to gather data, to publish a paper, to get it peer reviewed, to get it out there, right, is 3, 4, 5 years. And yet the company, for instance, wants to know how to use this tomorrow. And so there's been a clear mismatch between sort of our usual pathways of sharing information and knowledge through the peer review process that, has its merits and benefits and drawbacks as well. But I think this has really sort of amplified that to some extent. And it is changing things quite dramatically, I think, just with even, directly. So in terms of how do we share this information, the other is just the number of new problems, challenges that we're now starting to see as a result of this. Not only is there a backlog of all the papers, but just sort of all the new solutions that are needed, all the the questions that we're getting. Just how do I have a good interactive whiteboard to do brainstorming, for instance, on one of these calls, other than Zoom or whatnot, or how do I have better insight into my supply chain? So we're identifying all of these new problems that need research, need new advancements in development, that need to be tested, that will proceed sort of through the usual means and routes there. And so how do we do that quickly? Similar with Moriah saying, I'm busy doing this. It's like, well, I don't have time to track all of the calls and opportunities now for doing this, to write the proposal, to chase the money to do the study. And so just the speed with which all of this is happening, I don't know whether that, and at the same time, the volatility of it, right? And so what we think is sort of needed and or normal right now could be completely out the window tomorrow or an hour later when the FDA decides to change one of the regulatory, or issue a new emergency use authorization, right? And so it's just the sort of nice, stable, steady pace that we're all used to, I think is gone.
So maybe one of the things that, Melissa, you could step in and comment on, because you know more about this firsthand, is that I would say one of the things that will have changed for the future, I think, and permanently after this, is a sense of readiness, as Tim mentioned, right? If there is another pandemic that follows this some number of years down the road, I think a lot of the lessons learned this time and protocols and permissions put in place could be much more rapidly recreated and deployed. And there's been times where we envision something that we want to do that just isn't physically feasible to do or couldn't be done with the permissions in place at the time. And we've moved quickly to get them in place. But having now done that, we could change the guidelines for what the expectation is, for instance, on myself, to be able to write a protocol quickly, to get it turned around to the people who need it. And say the next time around, maybe be able to do this in even less time than we had done it here, or have more supplies on hand to have it be done with less of a rapid reagent scrounging to get things in place, which we had to do.
Yeah, and I think one of the things that will change also is the way that we think about consumables. And so normally our PPE is one of those consumables, especially in a high level environment. You use it once and you throw it away. And there are other things like that in a laboratory that that we consider consumables. And so if moving forward, these FDA approvals and emergency use authorizations go forward so that we can consider decontaminating, personal protective equipment and other things that we use in the laboratory that are normally thrown away, then we can be a little bit more prepared and have more things on hand, and we don't have to rely so much on the limitations of the supplies.
Thank you for that. Yes, go ahead. Tim.
No, I was just going to add to that. I think that's probably one of the biggest eye openers there is just even at Hershey alone, as we were talking with them, just sort of getting their inventory and supply chain group aligned with sort of what the new needs were and sort of the usual operational practices that we followed of every time we'll throw a mask away or do this or that. And it's like, we need to push back on sort of all of these assumptions, just given the shortcomings. And I think now we're seeing that, as the university is discussing about when do we go back to work and, who's going to get masked and who knows what's going to happen, when students come in the fall, do they get masked now as part of their student activity fee or what, I don't know. Well, they're still working on the assumption that they can actually call and place an order and get masked, which doesn't
ain't necessarily so. Might be fighting.
Yeah, and I don't know if you've seen some of the pictures of the the airports now and shipping docks in China, for instance, is this the delays and the pileups and the stack-ups of PPE and everything else. They're actually recommending, I heard the other day or read an article that it's actually now quicker to put something on a boat and ship it over here than it is to fly, get it through whatever airport screening and get it on a plane and fly it over. So that just shows you how backed up and backlogged things are just in that regard, let alone everything else. So I think it's just challenging sort of our assumptions and sort of fundamental way of operating on so many different levels here. That's really eye-opening and a bit scary at sometimes too.
So maybe I can add one more slightly different twist to your question about what will come in the future.
Sure.
Off of just the more narrow topics of our particular study, which has been, I think, insightful for us and also helpful to many other people, and I hope more still in the future. I hope that as this pandemic winds down, whenever that happens, that we don't lose what we've gained in terms of increased scientific literacy. I don't need to hear science as the top headline every day, especially when that science comes with bad news that we don't yet have a vaccine and that more people are dying. But I do think that there's a renewed appreciation for why it's important to know what a virus is, and that a virus is different than a bacterium, and that a virus, for instance, isn't going to reproduce outside of a host. So you have the ability to sterilize surfaces and to sterilize objects and contain or restrict, ask people to restrict their movement while sick. And then you can actually get on top of this. And that's really different than something that might be found in environmental sources in a reproducing way. So I hope that some of that scientific literacy stays high on people's agenda, even once the immediate fear is gone. And I think it's on all of us as scientists, engineers, any guides in which we might work and have the ability to explain biology, to keep doing that for people who feel nervous or daunted. Because it's all quite understandable, and the more you understand, then the safer you feel, and you can make educated choices about when to go out and when to wear a mask, and to feel comfortable wearing a cloth mask for most of the things that we do on a daily basis. These N95s that we're working so hard to be able to reuse are really not needed when you go to the grocery store. And they're not needed if you just want to be able to go to your workplace where you expect that other individuals are also healthy. So I hope that we have helped to make these things more accessible for healthcare providers, but also we don't get a chance to convey in our publication that, my mother or my father or myself, I don't need to have an N95 to go to the grocery store, and neither do they, even though they're quite old in terms of their age and their risk level. They're fine with a cloth mask for where they're working. And I think that's an important thing to convey and to keep repeating for the public so we don't seed fear at the same time as this virus is moving about.
Thanks, Moriah. Yeah, I share your hope for increased scientific literacy for sure. And I also would just say, after watching a really well put together documentary about the pandemic on Netflix, it's called This Pandemic Explained, which was a follow on from last year. They just did pandemics where they said this is inevitable and it's coming. And they had, Gates on there and others from around the world talking about this. I just want to share one little piece of that. They mentioned that the World Health Organization had, I think, 186 countries or something signing on to this thing saying they were going to get prepared for a pandemic. Like everybody said, yeah, of course. Oh my God, it's coming. No matter what, we need to get prepared now. They signed a dotted line and then nobody did anything. So nobody got prepared is what actually happened, because there's no sort of regulatory system. There's no teeth, as they say, to give them an incentive to be prepared. So my hope is that post-pandemic that we in addition to becoming more scientifically literate, that we take this stuff a little more seriously, make sure it's funded, make sure that the international community, creates some new regulatory systems to not only respond quickly, but also to get better prepared. I would hope that we'll be able to come together and do that. But I want to thank you all very much for coming on the show. It was wonderful to have you here sharing the inside story of what's going on in science right here at Penn State, plugging into that big global community. I wish you the best of luck moving forward as you continue to wrestle with all these elements in this crazy new world. So thanks again. And to our listeners, I want to say, keep coming back to the podcast and don't stop co-evolving.